In this second video for section 3.1, we're going to learn how to do determinants for matrices that are larger than 2 by 2. We need to get started with a new definition. We're going to start with a square matrix A. The minor of the element Aij is the determinant of the matrix obtained by deleting row I and column J of the matrix A. And we have this notation for the minor corresponding to Aij. We use a capital M for minor, and then the subscripts Ij to tell us which element we're talking about. And here's an example of a 3 by 3 matrix. And I've just written out all of the elements as if we don't know what they are. If I wanted to find the minor corresponding to A13, I would delete the row and the column corresponding to A13, and I end up with a new 2 by 2 matrix. And then I would need to take the determinant of this 2 by 2. So remember, to define the determinant of a 2 by 2 matrix, you take the product of these two elements on the main diagonal and subtract the product of the elements here on this other diagonal. We also need to know about cofactors. The cofactor of an element Aij is given by this formula. So it's -1 to the I plus j power. These come from the subscripts on A. And then we multiply by the minor of Aij. So essentially, the cofactor is going to be the same as the minor, but it might have a minus sign on the front, depending on whether or not I plus j is odd or even. Off to the right here, I've made a pattern of the pluses and minuses that correspond to the cofactors of a matrix. And I've just drawn it out for a 3 by 3. So this is the 1, 1 entry of a matrix. So -1 to the 1 plus 1, that's -1 squared, is +1. For this entry, we would have -1 to the 1 plus 2, which is 3. And -1 to an odd power is -1. And this is what the pattern looks like for the whole matrix. So you notice that the plus sign stays on each diagonal, so this diagonal and this diagonal. And then the minus signs also go on diagonals. Okay? And if I had a bigger matrix, like a 4 by 4, this pattern would continue. So the pluses and minuses just alternate. Let's do an example of a minor and a cofactor for this matrix A. So this one is a 3 by 3. We're looking at bigger matrices than the last video. We have 1, 0, 0, 2, -1, -2, and 3, 2, 1 on the columns. And what we're going to do is find the minor corresponding to the 1, 2 element. We want to find M, 1, 2. So we find the 1, 2 element, that's the first row, second column, this 2 here, and we want to delete this row and this column that correspond. So delete the first row and the second column. What's left over is the 0, 0, and the 2, 1. So we make that into a matrix and take its determinant. And this is a 2 by 2 determinant, so we know how to do it. we multiply 0 and 1 and subtract the product of 2 and 0. Both of these are 0, so overall we get 0 for our minor. Now we'll do the cofactor for 1, 2 as well. We want to find C12. And C12 is minus 1 to the 1 plus 2 power, so we're just adding 1 and 2. And then we multiply by the minor m1, 2. Minus 1 to the third power is minus 1, and we know that this minor m1, 2 is 0, since we already computed it. Minus 1 times 0 gives us 0 for the cofactor of 1, 2. Now we're ready to discuss the determinant of any square matrix. So a key to remember for determinants is that we're only going to talk about determinants for square matrices. But now we can talk about the determinant of a 3 by 3, a 4 by 4, or larger. Here's the definition. The determinant of a square matrix is the sum of the products of the elements of the first row of a matrix and their cofactors. So that's a little complicated. Let's see how it works out. I've written down a 3 by 3 determinant, and I've just written out the elements A11, A12, A13, and so on. So according to the definition, we're going to take the elements on the first row, A11, A12, A13, and multiply them by their cofactors. So A11 times C11, A12 times C12, and A13 times C13. And then we just take the sum of all three cofactors. Let's work through a little bit about what those cofactors are. So remember, a cofactor is the minor with either a positive or a negative sign on it. And you can think back to the 3 by 3 pattern from earlier, the plus, minus, plus across the first row. So this means we're going to have a positive cofactor for A11, or at least a plus sign on the front. And then we delete the first row and the first column. And what's left over is this, A22, A32, A23, A33. And then we take the determinant of this smaller 2 by 2 matrix. Then we go on to the A12 cofactor. This one had a minus sign in our pattern matrix, so we put a minus here out front. And then we go back to our matrix. We delete the first row, second column. And what's left over is A21, A31, A23, and A33. So we form that into a matrix and take its 2 by 2 determinant. Next, we go to A13. This had a plus sign in our pattern matrix, so we keep the plus sign here. And then we delete the first row and the first column and take what's left over, A21, A31, A22, A32. We form that into a matrix and take its 2 by 2 determinant. I've written out the rest of these determinants. So just starting here, we have A22 times A33 minus A23 times A32. So I've put that inside parentheses here and brought down A11 in the front. And then we go to our second matrix. We have A minus A12 here. And then we take the determinant of this 2 by 2, a21 times a33 minus a23 times a31. Okay, and then we need some more space. Now we add a13 times the determinant of this guy, and that's a21 times a32 minus a22 times a31. So that's a 3 by 3 determinant. We could just use this formula as our definition, but you can see this formula is pretty hard to remember if you just had to memorize it. And for a 4 by 4 determinant, this formula would look even more complicated. And if you were talking about really large determinants, 10 by 10, 100 by 100, this formula would fill up pages and pages. So it's better, or at least simpler, to use this recursive definition using cofactors. Let's see if we can do an example now of a 3 by 3 determinant. So we take the products of the elements of the first row with their cofactors. So we have 1 times C11 plus 2 times C12 plus 3 times C13. And then we find the minors. So starting here, we delete the first row, first column. We end up with this left over. We form it into a 2 by 2 matrix and take its determinant. And then remember the pattern. For the second cofactor, we get a minus sign. And then we delete the first row and the first column, and then we have this 0, 0 left over, and then the 2, 1 left over. Form that into a matrix, take its determinant. Then we move on to the third cofactor. This one has a plus sign in our pattern matrix. And then we delete the first row and the first column, and this is left over 0, 0, minus 1, minus 2. Form that into a matrix, take its determinant. On the next row of our work here, I didn't write the 1 down again since multiplying by 1 doesn't do anything, but we do need to multiply minus 1 and 1, and then subtract 2 times minus 2. And then move on to your next determinant. You have the minus 2 carried down, and then 0 times 1 minus 2 times 0. And then bring your plus 3 down, and then multiply by this determinant, 0 times minus 2 minus negative 1 times 0. So now you'll want to work through the arithmetic here. From here you'll get a minus 3, here you'll get a 0, and you'll get another 0 here. So both of these terms disappear, and the only thing left, oh excuse me, there's 2 minus signs. So minus 2 times minus 3 gives us a plus 4, and we end up with positive 3. So that's a 3 by 3 determinant.